Hello, year ones. How are you? Welcome to another problem of the week.
Hello, year ones. How are you? Welcome to another problem of the week.
Tautau, I just said that bit. I just said that bit about hello, year ones, and welcome to another problem of the week.
Did you?
Yeah, I did. I had to start without you. Where were you?
In the lavatory. Is that okay?
Yeah, of course it's okay. It's just I called and you didn't answer.
Well, next time, call a bit louder then.
Yeah, okay, well, you're here now. Should we start the lesson?
Good idea. What are we learning about today?
Well, we're learning about something that you know a lot about. It's in your name, actually.
Tau. You're learning about Tau?
No, we're not learning about Tau. That's a little bit advanced for year one now. We're learning about doubles.
Doubles. I love doubles.
Me too. Should we begin? Okay. We will start with a quick recap of what we looked at last week. It was arrays. Now, what can you remember about arrays? We saw that when you buy a tray of eggs, that comes as an array. So in an array, you have the same number in each row. These are two rows, the same number in each row. You also have the same number in each column. These are the columns going down. You can see there's the same number of eggs in each column. So an array is when you organize objects very, very neatly into rows and columns. And the rows are the same size. The columns are the same size. So it links to equal parts that we talked about in our previous lesson. So let's complete these sentences and think about how we can find the total number of eggs in the tray. There are how many rows? There are 2 rows we saw in green going across, and there are how many eggs in each row? There are 5 in each row. So how would we find the total then? What would we add together? There are 2 rows of 5. There are 2 groups of 5 eggs. That's 5 plus 5. And 5 plus 5 is equal to 10. So there are 10 eggs altogether. And what about these sentences? Let's look at the columns. So there are how many columns? There are 5 columns. And there are how many eggs in each column? There are 2 eggs in each column. What calculation would you do this time to find the whole? There are 5 columns of 2. There are 5 groups of 2. That's right. It's 2 plus 2 plus 2 plus 2 plus 2, which is equal to, well, we can count in 2s, can't we? 2, 4, 6, 8, 10. There are 10 eggs altogether. And of course it's the same because it's the same total of eggs. And we also spotted that the numbers are the same. 2 and 5. 5 and 2, just the other way around. Okay, let's move on. We're going to do some counting up and down in 2s. We're going to count up to 24 and down from 24 in 2s. Are you ready? Count with me. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Counting down from 24 in 2s. Are you ready? 24, 22, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, and 0. Same again, but this time using the Gategno chart. Tautau, you're up, counting up and down in 2s. Off you go. Okay then, count with me everybody. 3, 2, 1. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Counting down from 24. Let's go. 3, 2, 1. Count with me. 24, 22, 20,
18, 16, 14, 12, 10, 8, 6, 4, 2, 0, blast off! Yay! Well done, well done, well done. Same again with a different representation, and we'll try to go a little bit faster. Count with me in twos. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, counting down, 24, 22, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, and 0. Very well done. Now, look at this seesaw. What do you notice? How can you describe it? What can you see? Can you come up with a number sentence, an equation that goes with it? Well, I can think of one, and it is 1 plus 1 is equal to 2. Do you agree with me? Did you come up with the same equation? Because there's one child on each side, and altogether there are 2 children. Next one. What number sentence goes with this? It is 2 plus 2 is equal to 4. 2 children on each side, 4 children in total. What's your prediction for the next one? That's right, it's 3 plus 3 is equal to 6. What do you think's coming next? It's 4 plus 4 is equal to 8. And last one, what's it going to be? That's right, it's 5 plus 5 is equal to 10. There are 5 children on each side of the seesaw, and altogether there are 10 children. So here's all of the seesaws that we looked at. Let's have a think. Let's compare. What do you notice? What do all of these seesaws have in common? What's the same about them? Can you spot anything? You know, I think I can see maybe 2 or even 3 things that's the same about these seesaws. What can you spot? What about you, Tautau? What do all of these seesaws have in common? Can you spot anything? Well, let me see. Yes, I do spot something, all right. Well, look, you can see that in each case it's the same number being added together. Look, 1 and 1, 2 and 2, the same number, 3 and 3, 4 and 4, and 5 and 5. So in each case, you're adding the same number to itself. Well done, very well done. And I spotted something else. I wonder if you at home spotted something about the totals, the answers. 2, 4, 6, 8, 10. What can you say about all of those numbers? They are even, or they're the twos numbers. Isn't that interesting? And an extra challenge for you, if you've got time, you could think about what will come next if the pattern continues. And maybe after that, and after that again, you could draw the pictures and you could write the equations, the number sentences. But we'll move on. What we've been looking at here is doubling. Now, Tautau noticed that each time we're adding the same number. 2 plus 2, 3 plus 3, 4 plus 4, and 5 plus 5. We call that doubling when you add the same number twice. When you add a number to itself, we call that doubling. And that's what we're learning about today, doubling or finding double a number. Let's look at these examples. So we can see 1 plus 1, and that's equal to 2. Or we can say double 1 is 2. Next one. 2 plus 2 is equal to 4. Or you can say double 2 is 4. Next one. 3 plus 3 is equal to 6. Or you can say double
3 is 6. Next one. 4, what's it going to be? Plus 4 is equal to 8. Or you can say double 4 is 8. And 5 plus 5 is equal to 10. Or you can say double 5 is 10. Well done. Now, what do you notice? Looking at the tens frames, looking at our equations, thinking about the answers, can you complete the sentence? Doubling a whole number always gives what? How could you complete that sentence if you need more time to think about it and look at the examples and compare and think about what's the same each time, maybe what's different? Then do pause to give yourself time to come up with an answer, because I'm going to give you my answer here. Doubling a whole number always gives an even number, doesn't it? Did you spot that? Well done if you did. So we got 2, 4, 6, 8, 10. And we saw before, they're even numbers. They're twos numbers, the numbers we were counting in at the very beginning. So can you see a very, very, very important connection between doubling and counting in twos? And I know you're really good at counting in twos, so you're really good at doubling. So why do you always get an even number? Well, if you look at the tens frame, you can see an odd number always gets a pair. An odd number always gets a pair. And we're building up the numbers in twos when you look across at the rows. We're building up our numbers in twos. So again, important connections between doubling and counting in twos. Okay, so say them with me. Double 0 is 0. Double 1 is 2. Double 2 is 4. Double 3 is 6. Double 4 is 8. Double 5 is 10. And an extra challenge, can you continue? Double 6, double 7, double 8, double 9, double 10, and maybe even beyond. Now, here's a game you can play at home. It's called Doubles Snap. Have you played Snap before? Well, here we're playing it with doubles. So we have 2 piles of cards. These ones have the doubles. There's 2 plus 2. These ones have the totals. And then we turn them over, see if they match up. Is double 2 equal to 6? No, it's not. So next go. Is 4 plus 4 equal to 2? No, it's not. Next go. Is double 5 10? Yes, it is. So the first person to say snap wins that pair of cards. That might be fun. Of course, you can decide what double do you start with. Do you only go up to double 5? Or do you go up to double 10? Or maybe even double 12? Up to you. So some independent tasks for you to do in your own time. Number 1, look at the representations. There are 6 representations. Which show doubles, which do not. Put them in the correct place in the table. You can just write the number sentences. So something plus something, something plus something, rather than drawing the pictures. Number 2, it says take a number piece and double it. You'll recognize the numicon pieces here. You probably don't have those at home, but you can always draw them if it's helpful. And to double something, you just draw it twice. Then complete those sentences. Next activity, complete and continue the table. So we're looking at the representations. Here, we're doubling 1 with a tens frame. Here, we're doubling 1 with a beanbag. And here we've got 2 ways of writing that. Double 1 is 2, 1 plus 1 is equal to 2. And then we need to complete the other ones. This one, look, has that representation been completed? I don't think so. See, there's more gaps as you go on. Now we're following a pattern, so what's the next one? Then some problems to do that are a little bit trickier. So reading, thinking about what they say. Who do you agree with? Explain why, full clear explanation. Then we're working out some of these and thinking about what we notice. What's the same? What's different? And then same with these doubles. What do you notice? What's the same? What's different? What patterns can you see? I'm going to go through the answers now in a moment, so pause here if you need to go through those questions still. Okay, here are my answers, and I hope you agree with them. Now for these representations, I hope you spotted that this is double, just because you've got 6 fish in a tank and 6 fish out of a tank and in an array. Still double because it's 6 and 6. Same here. There's the same number of rows in each array. Just because these are a little bit smaller, that doesn't matter, it's just about the number. And this is a big die, that's a small die, but it's still 4 and 4, that is double. So we're not talking about size, we're just looking at the numbers. This is the table. I hope you got the same result. And for our 2 problems, here are some possible answers. I hope you came up with something similar. And I hope you're pleased with the work that you did with those.
Well done, year one!
Yes, well done. Very well done. Year ones, thank you, Tautau. Now, we do have one final challenge for you, and it is to look out for doubles over the week ahead. They are all around us, so if you look carefully, you will find lots of examples. Now, for instance, at the beginning of the lesson, I mentioned that you have a double in your name. Can you spot what it is?
Yes, Tautau, double Tau.
That's right. So what other examples can you find? That's it for this video. We hope you enjoyed it. Join us next week for another Problem of the Week. Thank you. In the meantime, take care of yourselves and we'll see you soon. Bye.
Bye-bye.
Bye.